Hello everyone, welcome to the first lecture on mechanics of materials. Let's see few of introduction topics to this. We have already seen what is the syllabus we are going through, what are the course outcomes, and what are the some of the prerequisite terms to continue in this course. Let us see the broad picture about mechanics and related aspects. See, first of all, whenever we look, the basic is always physics and mathematics, and there are various branches for physics and mathematics. You can see light and vision, sound and hearing, electricity and magnetism, thermodynamics, and mechanics. And from here, mechanics again classified into mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. Mechanics of rigid bodies again into statics and dynamics. Dynamics is again into particle dynamics and rigid body dynamics, that is one aspect. And kinetics and kinematics, that is the other aspect of dynamics. So in statics, what we expect is it is already been, you have been studied. Dynamics part will be looking at it in the later stage, in the coming semesters probably. And here in mechanics of deformable bodies, there are again, there are subtopics coming into, that is mechanics of materials, theory of elasticity, and theory of plasticity. This is what the order we study. And mechanics of fluids, so that is again a separate subject we will be addressing in the upcoming semester again. So this is what the broad picture is all about. This, what we study here related to mechanics. Okay, so we are just looking into this particular aspect, mechanics of materials. Okay, so let us see what is mechanics. Mechanics we define in this way. Mechanics is the branch of applied mathematics dealing with motion and forces producing motion. Okay, then how do we define mechanics of materials? Yes, mechanics of materials is a branch of mechanics, you have already seen. Mechanics of materials is a branch of mechanics, applied mechanics in fact, that deals with behavior of solid bodies subjected to various type of loading, various type of forces. Okay, it is also known as, sometimes it is called the strength of materials, sometimes it is called mechanics of deformable bodies alone, separately it is called. So the objective in the mechanics of materials is to determine stresses, strains and displacements in various structures and their components. Whenever the force acts, we will find all these aspects. So here we will be studying up to maybe the failure stage. Okay, so that is mechanics and mechanics of materials for you. So now let us see what is a deformable body and what is a rigid body. We have seen, in fact, we have seen mechanics of rigid bodies and mechanics of deformable bodies here. So what is a rigid body? It is better to understand what is a rigid body and what is a deformable body. Okay, so here it's a picture taken from sciencedirect.com. So just look at the, there is a body here represented with some dA, dx. Dx is a point, dA is an area, or dx is a line vector, I can say. dA is an area, dV is an volume, and there is a reference coordinate x1, x2, x3. I can say x1, xyz, or 1, 2, 3, whatever I can call. So this is the original body. When some force is applied, it is deformed into this shape. Okay. Now, as you here, you can observe uh, the orientation. See, whenever the body is displaced, whenever a force is acting on a body, it may get displaced. If it is just a rigid body, only the displacement, the orientation may change. So the shape, size, volume of the body is not considered into picture. But whereas if it is a deformable body, the dx, length of dx may vary. It may become dx, x plus dx, something like that. Area may change, area may increase or decrease, volume may change, increase or decrease, shape and size of the object may change, orientation of the subject may change. Along with this, along with this, some stress and strain will be induced or developed within the body. So that is what we call a deformable body. Okay, so if it is a rigid body, only the orientation may change. The change in dimension of the body, though there is a very small change in the body, that is negligible amount and that is ignored. But whereas a deformable body, the change in length, change in volume, change in area, change in size and shape of the body is considerable. Okay, so this is what we call elastic behavior of the body. That is what is considered in this. But whereas if the body is deformed excessively large, the quantity is excessively large, that is again not the case of study in mechanics of materials. Okay, I hope you understood the difference between deformable bodies and rigid bodies. Thank you.